Question number 26. If we subject gypsum to flame test, we will get a flame having dash color. Gypsum is nothing but calcium sulfate dot 2H2O. Here the metal atom present is calcium. Generally calcium will give you brick red color for flame test. Magnesium burns in air giving two products. The formulas are, see, generally magnesium when reacts with air, two types of products we can expect. One is magnesium reacts with oxygen, forms magnesium oxide, 2 moles, 2 moles. At the same time, magnesium also burns in the absence of oxygen. That means it reacts with nitrogen, forms Mg3N2. Two compounds are formed. One is MgO, other one is Mg3N2. So third option is correct. Next. Question number 28. BaC2 plus N2 on heating gives A. So here the A is BaCN2, barium cyanide. Whereas calcium carbide reacts with nitrogen on heating gives B, whereas B is nothing but CaCN2 plus C. Mixture of this CaCN2 plus C is called as nitrolim, which is used as a fertilizer. It is a fertilizer. Next. So what is A? BaCN2 and B is CaCN2 plus C. Third option is correct. Ionic nature of group second A hydrides are. So generally ionic character down the group increases. So down the group increases means last element is barium. So beryllium, magnesium, calcium, strontium, barium. So second option is correct. Which of the following is polymeric in solid state? So in solid state, polymeric structure is BeCl2 in solid. So we know that BeCl2 will write like BCl, BCl, here also Cl, Cl. So like this it is a polymeric structure. The alkaline earth metal which does not directly combines with hydrogen is beryllium. Does not combines directly with hydrogen. The most stable oxidation state of thallium is, thallium shows two types of oxidation states, that is thallium plus 1 and plus 3. Lower oxidation state is always greater than higher oxidation state due to inert pair effect. Inert pair effect. So plus 1 state is most stable than plus 3 oxidation state. Next. Aluminium and gallium have the same covalent radius because of, so generally aluminium and next one is what, gallium, they have same covalent character due to poor shielding effect of d electrons. Next, the hybridization of orbitals of central atom in BOH taken 4 all to the power minus and the geometry of the complex are respectively. So barium has 4 OH groups, that means it is surrounded by 4 OH groups. Maximum valency, that is covalency of boron is 4, right? That's why it can react with 4 OH groups and the hybridization becomes sp3. When hybridization is sp3, shape of the molecule is tetrahedral. So first option is correct. Next, 35. Aluminium forms AlF6 whole to the power 3 minus, but boron does not form BF6 whole to the power 3 minus because of absence of d orbitals in the case of boron. So remaining elements has d orbitals, that's why their electronic configuration can be expanded. Next, 36th. BCl3 when reacts with lithium aluminum hydride, this is LiAlH4, gives A plus LiCl plus AlCl3. Here A is diboron, B2H6 is formed. So now A, diboron reacts with the A is B2H6, right? B2H6 reacts with water, gives B plus H2. B is nothing but boric acid, that is H3BO3. Now this boric acid, when passed through red hot, that is heat, will get C. C is nothing but boric anhydride, or we can say B2O3. So B2H6, H3BO3, B2O3. Second option is right. Next. With a given anion, the correct stability order of tetrahaloborates. So stability order, if you see, BCl4 minus is more stable than BBr4 minus than BI4 minus. So down the group, stability decreases in the case of halides of borons. Density is highest for, so down the group, density increases. Lead is more denser among all the 14th group elements, right? Actually the order is what, so generally silicon is less than carbon, then germanium, then tin, then lead. So carbon also, that is diamond form. So highest, that is density is there for lead. Hybridization state of central atom in SnOH taken 6 all to the power 2 minus is. So here steric number is 4. When steric number is 4, hybridization becomes sp3d2. So option 4th is correct. That is sp3d2 is the correct answer. Next. The element which can have unique ability to form p pi multiple bonds with itself and with other atoms of small size and high electronegativity is obviously that is carbon. So carbon can form multiple bonds. In that the hybridizations, that is what it shows different types of hybridizations, that is sp, sp2, sp3, and it can combine with some other small elements like oxygen, nitrogen, etc. The order of catenation power is, highest catenation power is there for carbon, then silicon, germanium, tin. Down the group decreases. The hybridization of carbon in diamond, graphite and acetylene are, in diamond hybridization is sp3, whereas in graphite is sp2, acetylene is sp. So second option is right. Silicones have the general formula as R2SiO. So like this we discussed SiRRO. So this is the basic unit of silicones. Identify B in the following. H2SiO4 when heated at 1000 degrees centigrade loses water molecule, gives A, which gives B on reaction with carbon by heating. Right, along with the B, CO is also formed. So what is B in this compound we have to identify. So 44th question, if we see, when H2SiO4 is heated, we'll get silica, SiO2. Silica when treated with the what we call carbon and further heating, then we'll get SiC. This is nothing but carborundum. So fourth option is correct. Which of the following statement is not true about the diagonal relationship of beryllium and aluminium? So their chlorides are insoluble in organic solvents. Yes, this is correct. So no need to see remaining, right? Next. Question number 46. What is the maximum covalency of silicon? Maximum covalency of the silicon, if you see, that is 6, right? Maximum covalency 6. Maximum, 47th question. Maximum number of oxygen atoms are bonded with each silicon in SiO2 structure is. So maximum how many? 4 are there. How we know the structure? That is SiO, SiO, Si, like this. It will expand O, Si, O, Si, silica structure. like this. See here, each silicon is surrounded by 4 oxygens. Here one, here one, here one, here one. Total how many? We have 4 atoms. Right. Next. So the answer is 4. Next one is 48. Total number of moles of water in 1 mole of Epsom salt is nothing but MgSO4.7H2O. So total number of water molecules, how many are there? 7H2O. 7 molecules of water is present. Next, 49. Moles of hydrocarbon produced by hydrolysis of 1 mole of Mg2C3, that is magnesium carbide, are. So the reaction is Mg2C, on hydrolysis we get magnesium hydroxide, MgOH taken twice, plus. So this is nothing but Mg2C3 gave, right? Then it is CH3C triple bond CH, that is propane is formed. So what is asking? The moles of hydrocarbon produced by hydrolysis of this compound is asking. So total how many are produced? 1 hydrocarbon is produced, that is propane. Next, the last one. When calcium carbide reacts with nitrogen in a compound X is formed. X on reaction with H2SO4 gives Y and CaSO4. Then the number of sigma bonds in compound Y are. So first of all, let us see the reaction. CaC2 reacts with nitrogen is said. When it reacts with nitrogen, we'll get CaCN2 plus C. This is nothing but nitrolim mixture we discussed, right? So whatever CaCN2 is formed, that is reacting with H2SO4, sulfuric acid. Then CaSO4 is formed. Along with CaSO4, we can also get H2. What is left here? NCN is formed. Now let's see the structure of this compound. N C triple bond N H H. So in this compound, total number of sigma bonds, how many are there? Here 1, 2, 3, 4, 5. Right. So here it is not 5. Let's see the last compound. Again I write the structure so that easily. So this we can also write it as N H H C triple bond N. So here total number of sigma bonds is asking. The sigma bonds are C1s. All single bonds are sigma bonds. Here 1, 2, 3. In multiple bonds, one of the bond is sigma. So total how many? 4 bonds are present. Thank you.